Hello, one and all. Hello. This question is on, as it says there, gas. Okay, so we've done gases before, but here's another one. So the question is, a gas of volume 0.25 cubic meters. I don't know why my font or my subscript is that. So we've got a gas of volume of that much, 0.25, and a pressure of this, 500 kilopascals, 500,000 times 10 to the 3, right? Initial temperature of 62. So we've got a gas volume, right, and a temperature and a pressure. The gas is then compressed to 0.1. We're squashing it to 0.1. That causes a bit of heat, 200 degrees C. So it's been squashed and heated up. We've got to calculate the pressure after the gas has been compressed. So this is the law that you need. P1 V1 over T1. P is pressure, V is volume, T is temperature. That's before we do something. That's got to equal P2 V2 over T2. That's what we need. So we've got to write down what we know. So P1 is the pressure before we do anything. So P1 is going to be 500 kilopascals times 10 to the 3. That's P1. V1 is 0.25. 0.25 cubic. Move down a bit or zoom out perhaps. This one's not it. Something like, no, okay. That'll do. No, okay. No, okay. Oh, yeah. Right, here we go. So, get rid of that pen. So P1 is that, V1 is that, and T1 is going to be, get a pen back here. T1 is going to be 62. We can't use 62. It's got to be in Kelvin, so we're going to add 273 to that, which gives us something like 335. It can't be in degrees C, we've got to be in Kelvin. You've got to add 273 to it. Okay, so we know P1, we know V1, and we know T1. Different clue pen now, what is? Let's go for on it. So now, the gas is then compressed to 0.1. So V2 now is 0.1. We're squashing it. Right, that's the change. Gas is compressed to 0.1 and heated to 200. So T2 is going to be 200. Can we use that? No, we can't. Correct. We've got to add 273 to it. So we've got to turn it into Kelvin. That gives me 473K. Make sure you put everything in Kelvin. So that's 200 in K. We know the volume has been squashed. We need to find the pressure after. So we need to find P2. I don't know what P2 is, but I know this formula. Okay, so I'm going to rearrange this formula now to get P2. Scroll down a bit. P1 V1 over T1 equals P2 V2 over T2. Okay, I want to leave. I want to keep P2 on the right hand side, really. Right hand side. So I'm going to move everything across. So I know that T2 is divided by, so I'm going to bring it up. So to move it across, I'm going to times it. So P1 V1 T2 over T1 equals P2 V2. What I've done there is brought the T2 up, look. It's divided there, so I've multiplied it, brings it up. And then I'm gonna, this is P2 times V2, So I'm going to divide, let's get rid of that. I'm going to go P1, V1, T2, divided by T1 times by V2, because I'm going to times it. So I divide it, I'm dividing it, that's times. So I'm dividing it by V2. That equals P2. So P2 is now by itself. This is the formula you want to use to find P2. Okay, so we know that P1, what was P1? P1 is 500. So all I'm doing now is putting these numbers in. 500 times 10 to the 3, because it's killer, times by, what's V1? 0.25. So times by 0.25, times by T2 in Kelvin, which was T2, not T1, T2, 473, 473, 473, 473. That's all of that. All divided by T1 and V2. T1 and V2, look. T1 was 335. There, look, 335. So 335 times by V2, which is 0.1, because we're squashing it. Whack that in your calculator, and you should get an answer. You should get an answer like this: 1764925.373 Pascal. There's nothing wrong with that answer. If you want to move this decimal place to get it into engineering notation, 1, 2, 3, 4, 5, 6. 1.76. 76 for like a 5, should we? There we go. That's times 10 to the 6 Pascal, or 1.765 megapascal. And that is P2, which makes a bit of sense because it starts off at 500, isn't it? And we're squashing it. So if you're going to squash something in a container, it's going to increase the pressure in it. Got to, because there's less volume, so there's going to be more pressure. So it starts off at 500, we squash it a bit, and it ends up at 1.7 mega. That's killer. Okay, so it's gone up. So that's the question. Ready, Benny? Thank you very much. That's the value for P2. Hope it helps. No star.